welcome.
Okay, so the first method is something called long division. So here's when you use long division. So write these notes down. When the power on the numerator, so you have a polynomial on top, you have a polynomial at the bottom, and you have the power of the numerator is greater or equal to the power in the denominator. Okay, and then both are polynomial functions. So in AB, they usually just ask linear functions. Can you see you have a line on top, you have a line on the bottom? Correct?
Yes.
Have a look at number 1. So in AB, they ask very, very simple questions. So here's what I'm going to do. I'm going to do long division. Okay. So it's like 5x minus 3. And you have 2x minus 5 outside. But we run into a problem immediately. Can you see 2 doesn't go into 5 evenly? Am I making sense?
Yes.
From IM3, 2 doesn't go evenly into 5. So I created this method. So watch this. We'll take the LCM of these numbers. What's the lowest common multiple of 2 and 5?
10.
10. So guess what? Can you see 2x goes into 10x? So if you had a 10x on top, can you see the problem can get solved very, very quickly? So my goal is to create the LCM, generate an LCM and then adjust the numerator. So here's what I'm going to do. Write this down, please. So I'm going to do 1/2 and then multiply the top by 2. So it'll become 10x minus 6. Write this down in your notes. I just multiplied the numerator by 2. Is that clear? But I cannot just simply multiply the numerator by 2, so I divide it by 2 also. Does it make sense? To balance it. Here, Ms. Andelkovic is frowning. Here's what I'm really doing. Is that okay? 2 over 2. And I multiply the 2 here and pull out the 1/2. So I get 2 times 5x is 10x, 2 times negative 3 is a 10x minus 6. All over 2x minus 5. Just so that you understand what just happened, because 2 goes into 10x 5x times, and then 2 goes into negative 6 negative 3 times, and we have the original problem. Do you see that? They're perfectly equal.
Oh.
Okay, this is the time you ask me, I'm lost. I don't know what you did today. I just multiply the numerator by 2 and then divide by 2. So it balances out. Now I'm ready to do long division. I need a 10x, I have a 2x. So what should I multiply by?
5.
5.
So see if this comes back. I'm going to distribute. What's 2x times 5?
10x.
10x.
What's negative 5 times 5?
Negative 25.
25.
Now see if this comes back from your last class. Should we subtract?
Yes.
Switch the sign.
And then we should switch the sign, right? If I'm subtracting, just switch the sign. So that will collapse. What's negative 6 plus 25?
19.
19.
19.
19. We're done. We're done. Can you see 2x doesn't go into 19? So we're good to go. So I'm going to rewrite the original problem this way. So 1/2 integral. Now from your IM3 class, I'm going to write something, see if you're okay with that. So your quotient is 5. Your remainder was 19 and divided by the divisor, which is 2x minus 5. Does that vaguely come back? So we can write the original problem this way. So that's what I'm going to rewrite it as. 5 plus 19 over 2x minus 5 dx. Now, just to be clear, what I'm saying is, I'm writing this in blue. Okay, I'm writing this in blue so you can see the board. I'm saying the original problem of this guy is the same as doing that guy. Because I just divided 5x minus 3 over 2x minus 5. Is everybody okay with that first step? I just rewrote the original problem by doing long division as this problem. Now, this can be integrated very easily. What's the integral of 5?
5x.
5x.
plus 19. Hint. What's the integral of 1 over monkey?
ln
ln
absolute
absolute
value.
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 Careful.
Over 2.
Over 2.
Over. Ta-da! And that's the end of the problem. Okay, technically, so Chawla doesn't score me plus C, right? It's an indefinite integral. Okay, can you take 30 seconds to look over your work? Take 30 seconds. So the problem began life by quotient. You're a linear line on top, you're a line on the bottom, and we cannot integrate that. We know no method that allows us to integrate that. You have 5x minus 3 on top. So I did long division. But the problem with the long division was 2x doesn't go into 5x. So guess what? I'll multiply the top by 2 and divide by 2 to balance it out. And then I did long division. It worked out beautifully. Relax, we'll do another problem. We'll do a definite integral problem. Copy down number 2, please. So we will do the problem as a regular problem. In the last step, we'll apply the limits, yeah? Okay, I want to see if learning happened. 4 doesn't go into 3. So what's the LCM of 3 and 4?
12.
12.
So should I multiply the top by 4?
4 over, yeah.
And to balance it, I should also
Pull out the 4 at the bottom.
divide it by 4?
Yeah.
Is that clear? So I'm going to rewrite it as 1/4 integral 0 to 2. What does the numerator become?
12 t minus 8.
All over.
40.
14 minus 3.
Is everybody okay there? Now can I just do long division? Because 4 totally goes into 12. So I'll do long division. 12t minus 8, 4t minus 3. Okay, look down. I'm going to walk you through it. I need a 12. I have a 4.
3.
3. So that becomes 12t minus
9.
9. Okay. See if that comes back. I'm distributing. Subtract. So switch signs.
1.
So your remainder really is
1.
1. So I can rewrite the original problem as 1/4 integral 0 to 2. Okay, see if you can do the rewriting yourself. What do I write?
3 plus
plus
1
1 over
over 14 minus 3.
2.
You mean 40 minus 3?
Yeah.
Can we easily integrate this?
Yes.
Okay, look down. Look down. 1/4 integral of 3,
3t
3t.
3t plus
ln absolute
ln
value of monkey
value of
over 4.
minus 4. Over 4.
lower limit.
0.
0.
0.
Upper limit.
2.
2.
Look down. Look down. Look down. I'm not doing anything clever. I'm just plugging it in. Bring down the 1/4. Go.
6 plus
Plus
ln
1/4 ln
5.
5. 4 times 2, 8. Take away 3. Minus
Parentheses.
parentheses
0
0.
plus
plus
4.
4 ln
And negative 3.
3.
3.
Absolute value. Absolute value.
3. 3. 3.
3.
Yeah, become positive 3. Okay,
Yeah.
absolute last step. I'm going to open this up. 1/4. 6. Okay, we did this earlier, 2 chapters ago. See if this comes back. Everybody look at the board. I'm writing in red so you can see what's going on.
Condensed.
I have 1/4 ln 5 and a negative 1/4 ln 5. Can you see there's a negative sign?
Mm-hmm.
So I'm going to show log rules from the previous chapter. See if this vaguely comes back. Okay?
5 over
Stay with me. Plus 1/4 is positive. That's ln. Who remembers the quotient rule?
5 over
ln
3.
5
5
minus
over-
ln 3.
5 over 3.
That
Five.
5 over 3. Observe, I pulled out that 1/4. You can leave Brittany alone or you can distribute. If I were to distribute, what's 6 over 4?
3 over 2.
3 over 2. In case you say, what am I doing? I'm distributing. Is that clear? And what's 1/4 times 1/4?
1 over
Yes, 1 over
16.
ln 5/3. That is your final answer. It wasn't too bad, was it?
No.
It just has a lot of steps, but you just have to be careful. Okay, on your homework, please, for your own sakes, check your solutions with Ms. No. This is a definite integral, so we do not write plus C. Okay. Put your pencils down. So let's talk about it. So when do we do long division again?
Is when the power of numerator is greater than or equal.
Greater
to-
or equal to. Okay, we're just doing equal to, but totally I can have a higher power on top. I can have a Rama on top. But otherwise, for AB, usually you just have a line on top, line on the bottom. Is it fairly straightforward?
Yes.
Yes.
Okay, you just have to be very, very careful and attentive in doing every step. Do not skip steps. If you attend office hours, we'll do number 3 and we'll do number 4. But otherwise, we're going to move to the new lesson. This is the most important lesson. So it's called differential of a function. Write that down, please. We're on page 5. Okay, we're on page 5. Now, this is the bulk of today's lesson. So pretty much all of today we'll be doing this. Now I'm kind of cautioning you. Some students will be confused at the end of the lesson, as Mr. Gurbani usually is. Gurbani admits, he'll say, yeah, I was confused. But he always attends office hours and masters the lesson. By the time he goes home, he says, yeah, I get it. Okay, so for your own sakes, be responsible, attend office hours. It's your choice, but understand, grasp that if you choose not to attend, you will be confused on your homework. Okay, so first we'll do something called a differential of a function. Earlier we did this. So y equals f of x. And I'm taking derivatives. Is the notation dy over dx? Yes?
Mm-hmm.
And then on the right-hand side, can we write that as f dash of x?
Yes.
Yes. Now here's what a differential is. Everybody look at the board. We only write a dy. In other words, dx should vanish. So what can I do to both sides to get rid of dx?
Multiply by
So it becomes dy equals f dash of x dx.
yes.
Yes.
Mhm.
That is called the differential of y. Okay, that's called the differential. So, sharp kids, can I skip a step and write this directly? Can I go from here to here directly? Can I just take dy equals f dash of x dx? Can I just put a dx at the end?
Yeah.
Mhm.
Makes sense as a shortcut. I don't need to show dy over dx and then cross multiply, correct? Why don't you just take the derivative and just write dx at the end? Okay, that's what we'll do. All right. So copy note number 1. It says find the differential of. You don't need to copy the question. Just say u equals radical of 5x minus 4. I will do this. So do this with me. Yeah. So du instead of y, they have u equals. Okay, guys, we're doing slopes. What's the slope of radical monkey?
1 over
1
2.
over 2 radical monkey.
5.
5.
5x minus 4 chain rule times.
5.
5.
And what do I write on the right hand side in the last step?
dx.
Dx. Very
X.
smart. That's the differential. This wasn't too bad, was it?
No.
It's that easy. It's that easy. Let's do a few more problems. Guys, yesterday I said make sure you come prepared to class having memorized your derivative and integral formulas. Okay, copy note number 2, please. U equals cos inverse x. Okay, let's do this together. So du equals, okay, who vaguely remembers from the first semester the derivative of cos inverse?
Negative
Negative
1
1
over radical 1 minus x squared.
1 minus x squared.
What do I not forget to write?
dx.
Yeah.
dx. It's that easy. Okay. Right on page 6. Guys, moving forward, so you can write a page or just a question number because I've numbered the questions now. Is that clear? You don't need to write the page numbers. Just number the question. Today, for a change, I've numbered the questions. Okay, let's go. So du equals
Negative 1 over x squared times dx.
times dx. There you go. It's that easy. It's that easy. Okay, now I'm going to do a second step. Everybody, look at the board. I'm going to solve for dx. Everybody, I'm going to solve for dx. Let me show you how to do solve for dx. Look at the board. I'm going to solve for dx. So should I multiply by the reciprocal to get dx equals, if I multiply both sides by the reciprocal, will I get negative x squared du? Are you able to do that in your head? I'm just multiplying both sides by the reciprocal of this guy. Everybody look at the board. Again, I'm solving for dx. That's today's lesson. I will solve for dx. Next step. So I'm just going to multiply both sides by the reciprocal of -1 over x squared. Is that just negative x squared over 1?
Yes.
And I'll get du. So we'll do that for the next two problems. Is that clear? We will solve for dx by just multiplying by the reciprocal. Okay, copy down number 4. So we'll do 2 steps. Think of it as a small game, okay? Ms. Ramirez, you doing okay?
Yes, I'm doing good.
Mr. V, you're doing okay? Mr. V?
Yeah, I'm doing good.
Okay. So du equals first step. Okay, go. We're just doing derivatives, guys. Go.
6x squared minus 10x times dx.
dx.
I'm going to multiply both sides by the reciprocal. So dx equals
du
du
over
or rather 1 over
minus 10.
6x squared
That-
minus 10 du. Yeah, you were not incorrect. You were not incorrect when you said du over. That's okay.
Okay.
That's okay. That's okay. Did everybody get the hang of it? I'll just multiply both sides by the coefficient of dx. Okay, whatever dx is next to dx, I'll just multiply. Okay, let's do question number 5 the same way. So du equals 3. Okay, is that sin x or sin monkey?
Sine monkey,
Okay, what's the slope of sin monkey?
cos monkey
Cos
times 2
monkey
times
times
2.
dx.
Mhm.
Okay, now I'm going to multiply both sides by that reciprocal. So dx equals
1 over 6 cos 2x times du.
x times du.
is everybody okay there? Did everybody get the hang of this? Okay, now we'll do an old problem in a new way. Copy down number 6, please. We just finished doing a question like 6. Now I'm going to teach you something new. It's called U substitution, but just play along. Initially, just play along. First, write down method 1. We'll integrate this directly. So equals 9, go.
Times ln absolute value of monkey over 5.
5x plus 2 over 5.
Mhm.
Is everybody okay there? Okay, now I'm going to show you a slightly longer way to do the problem. And now you're saying, but Rama, are you being an idiot? Why would you show us how to do a longer? Why would you show a longer way? Because the method, the longer way I'm going to show you works for the rest of the problems. So for this simple problem, we could use a shortcut. But for in the future, I'm just letting you know, in 5 minutes down the line, let me just scroll down so you can see how complex the problems are. Can you see? That's a much more complex problem. Do you see that?
Yes.
Have a look at that problem. It's far more complex than what we have done. So for these questions, this new method, the longer way will work. So I'm showing you a longer way, but apply to a simpler problem. Am I making sense? So you can see connections, saying, oh, I see what's going on. Okay. So here's what I'm going to start with. Remember that was 1 over monkey. I'm going to call the monkey u. Just play along. So let u be 5x plus 2.
Mhm.
Remember it was 9 over monkey. Now pay very, very close attention for the next 5 minutes. If you get distracted, you are going to lose the lesson. Okay, everything will just be gobbledygook. If you do not pay attention for the next 5 minutes, you're going to lose. Next, we're going to take the differential. Okay, so du equals
10 5
5.
5
5 times dx.
dx. Next step, should we solve for dx?
Yes.
Mhm.
So dx equals
1 over 5 times du.
du.
is everybody okay there so far? Okay, now I'm going to do something called U substitution. Write this down, please. You're learning a new method. It's called U substitution. Now, here's my goal. The original problem, can you see you have an X? That X should vanish and only U's will appear. Okay, play along. Just play along. So equals, I can pull out the 9. 1 over. Look at your notes. Look at your notes. What can I rewrite 5x plus 2 as?
And then
No. What can I write 5x plus 2 as?
You.
U. Look at the board. Look at the board. Can you see 5x plus 2 is just U?
oh,
1 over U. And then what can I write dx as?
1/5
5 1/5 du.
du. Did you observe? Only u's appeared. X's have vanished. Did everybody understand this? All the x terms have vanished. Now that is the key step. Make a note to yourselves. x's have vanished. If x's do not vanish, then you made a mistake. Is that clear? X's have completely vanished. Now, this is very, very easy to do. Next step. Can I pull out the 1/5 and write the question as 9/5? Yes. Can I pull out that constant? And am I left with 1 over u du?
Mm-hmm.
Yes. Okay, let's wrap this up. What's the integral of 1 over u?
ln
U. Ooh. What was u in the beginning? Look up. What was u after all?
5x plus
5x.
2.
5x
5x plus
2.
2.
Oh wow.
Wait a second. Did we end up at the same spot? Look at look at method 1. Look at method 1.
Yes.
Did we end up at the same spot? Using a method called u substitution. So in the very last step, make a note to yourselves. We just substitute u. Make a note. Substitute u. And that finishes the problem. Now, what I just showed you is called u substitution, where we were doing a simple problem using a slightly longer way to show you the process of u substitution. So can you go back up and see how we chose u? The key step, the challenge with these problems is choosing u. So for most of the problems, whatever monkey is, we chose u to be monkey. Is that clear? And it worked out very fast. Take 30 seconds, look at every step. So when we take the differential, the key step is u substitution. All the x's should vanish and only u's should appear. Integrate with respect to u, substitute back in, and there's your final answer. Let's do another problem. Copy down number 7, please. Okay, let's do method 1, the shortcut. 5. Okay, go. What's the integral of 1 over radical monkey?
2 radical.
Radical monkey
Over 4.
over 4. Is that same as 5/2 radical? I'm simplifying the fraction, yeah?
Mhm.
Plus c. Is everybody okay there?
Yes.
Okay, now let's use method 2, which is u substitution. Okay, I want to see learning happen. Feel free to peek at your notes. What should I choose u to be?
Radical 4x plus 1.
Just 5x plus 1.
4x plus
Sorry, just 4x plus 1. Don't choose a radical. Remember, I just said, what's the monkey? The monkey is just 4x plus 1, correct?
Mm-hmm.
Okay, so it's 4x plus 1. Okay, go. Next step.
du equals 4 times dx.
Next step.
dx
equals
1 over 4 du.
du.
Is everybody getting the hang of this? Okay, now key step. We're ready to do u substitution. Everybody, this is the big idea. All the x's should vanish and only u's should appear because it's called u substitution. So play along. Equals, I'll pull out the 5. Yeah, I'll pull out the 5. Integral. What can I write instead of 1 over radical 4x plus 1? I should write only u's. So 1 over
Radical u.
radical u. Everybody okay there? Look at the arrow on the board. Everybody, look at the arrow on the board. I'm just going right to left. What can I write for dx?
Times
1 over 4 times du.
du.
Is everybody okay there? Will the 1/4 like in the previous one come out?
Yes. So
Yes.
5 over 4.
Is that 5 over 4? Stop. I'm just going to cross this out so we can skip a step. Ooh, what's the integral of 1 over radical u?
2 radical u.
2 radical u. And then absolute final step. But what was u after all?
4x plus 1.
4x plus 1.
Radical 4x plus 1 plus c. I simplified this. I got that. Ta-da! You see that perfectly equivalent.
Mm-hmm.
Did everybody kind of get the hang of the process of how u substitution works? Sorry, Ms. Andelvovic, what did you say?
Where did you get the u, du, and dx? I got a little lost right there.
Oh, here. What is dx after all? I'm substituting. Dx is 1/4 du. So I replace dx with 1/4 du.
Yeah, I understand the substituting, but where did you get dx from? Where did it equal?
Oh, here. You mean I'm drawing an arrow? See, this is where you lost. I'm drawing an arrow. Is it from here to here?
No, I got that part. Where'd you get u from?
Oh, that's just the first step. I just chose, remember it was 5 over radical monkey, I chose the monkey to be U.
Okay.
I just made it up. I just made it up. Like in the previous problem, Ms. Undercover. It was 9 over 5x plus 2. So it was 1 over monkey. We just call the monkey U equals 5x plus 2.
Okay, so we just use the monkey for U?
Pretty much. Or rather, let me say 80 times out of 100, yes. So relax. So Ms. Andelkovic, I hope I'm saying your name better now.
Yeah.
Today's challenge is choosing you. That's the lesson. The lesson is how do we choose you? Because I hope the rest of the process is fairly straightforward.
Yeah.
So the challenge is really how to choose you. Okay, everybody, now I want you to go home. Actually, you're at home, so joke. Go home and take a printout of page 9. Make a note to yourselves. Take a printout of page 9. So this page, Ms. Andelkovic, gives you how to choose you.
Okay.
All right, everybody, put your pencils down. So I'm giving you tips because that is the challenge. So for composite functions, if you have f of g of x, choose u to be the inside guy, basically the monkey. Okay, choose the inside guy to be u. So I'm giving you examples. Have a look at the examples. So if you see sine of ln x, can you see it's sine of monkey? Do you see what I'm saying? You choose the monkey to be u. So choose u to be ln x. That is example 1. You don't need to write, just watch. Have a look at example 2. Is that actually cos inverse of monkey? So we choose u to be 3 sec x.
Mm-hmm.
Do you see what's going on? Observe patterns. Remember, intelligence is observing patterns. Flores, sweet girl, how are you doing? Are you getting the hang of at least some of it? Flores. Flores, unmute yourself. Miss Flores? I don't know if she has Wi-Fi issues. Okay, have a look at number 3, please. Take down number 3. Take down number 3. Because that's a famous problem. Everybody, take down example 3. So it says e to the power of 3 radical x. Is that basically e monkey? So we chose u to be 3 radical x. Is that clear? Now number 4. Don't write, just watch. So it's cube root of monkey. It's a complicated expression. We choose u to be. So once again, Ms. Chawla, we did not choose u to be cube root of. No. Just the monkey. Okay. Have a look at number 5, please. Is that 1 over radical monkey? And we just chose the guy underneath the radical to be u. It's like 1 over radical monkey. Again, intelligence is observing patterns. Have a look at number 6, please. Is that just ln monkey? So these are all composite functions. Can you see? A complex function of a simple function. So we choose a simple function to be u. And then number 7, that's x squared monkey. So we choose u to be sine inverse x. 8, 9. Have a look at 9, please. Is that kind of like 1 over monkey square? Do you see that pattern? Is that 1 over monkey square? So we chose monkey to be u equals ln x plus 1. Now there are some tips. So write these down. Write down. So this is Roman numeral 1. This is Roman numeral 1. So write this down. So I'm giving you tips. For a rational function, just say f of x over g of x. A good tip is choose the denominator to be u. So write that down, please. U equals g of x. Again, Roman numeral 2. If you have f of x over g of x, you want to choose a denominator to be g of x. If you have, write down Roman numeral 3. If you have a radical function, so you have nth root of f of x, choose the u to be the underlying function, basically monkey. Likewise for Roman numeral 4. If you have a power, f of x to the power of n, choose the base. Monkey to the power of n, choose monkey to be the base. Okay? Now, these methods will work. The tips I've shared with you will work 99 times out of 100. Repeat, 99 times out of 100. So you may say, Rama, so what about the 100th guy? The time these tips do not work. Then this big idea works. Write down the big idea. So the big idea works 100 times out of 100. Write this down, please. So choose u so that its derivative is already present. So I will go over the big idea when we do examples. Okay, write down big idea. So we're really, really choosing u so that its derivative is already present in the question. Is that clear? Write that down. That's a very, very important idea. Girls, if you have highlighters, highlight that. That's the big choice for choosing u. Okay, now we're going to start for the next 1 hour. We'll only do u substitution. All right? Play along. Miss Flores, are you there?
Yeah, I'm here.
Okay, silly girl, unmute yourself. You're annoying me. Mr. Trees, you're doing okay?
I'm following along so far.
Mr. Smith, congratulations on your last test performance. You got an A or A plus, by the way.
Yeah, I saw. Thank you.
Okay, guys, copy down number 8, please. Now, it says find the following integrals using U substitution. Okay, I'll start you off. You have a cos x and you have an E monkey. Do you see that? Repeat, you have a cos x and an E monkey. So what should I choose U to be?
Sin x
Sin
times
x.
dx.
You see? Okay. Therefore, du equals
Oh, sin x, or no. Sin x
Cos
times,
x?
no, cos x times dx.
we're taking derivatives, right?
Yes.
Next step. Therefore, dx equals
1
Whatever.
over
Cos x times du.
U.
everybody okay with these 3 steps? This will happen mechanically for every problem. Okay, this is the time you can unmute yourself and say, Rama, I don't get this. I will not scold you. I will not scold you. I will not shame you.
Rama.
Yes.
So I think there isn't a confusion for like lots of when you said like sin x, I think they thought like you got the derivative of cos x instead of putting the power there.
No, what are you saying? Say that in English.
Like when you got the sin x,
Yeah, because this was E monkey. Our rule was if you have a composite function, you choose monkey to be U. So we chose U to be sin x, and then ignore the question completely. Ignore the question. Then we just do differentials. Du equals cos x dx. We take the reciprocal of cos x. Therefore, dx equals 1 over cos x du. What's your question now?
I didn't have a question. I was just saying like maybe some people got confused when you said sin x, it means like the derivative or like an integral from cos x. In the
Okay, this was example number 1. I don't think kids are confused with the first example. Maybe they'll get confused later, but not now. Okay, let's move on, guys. Okay, next step, everybody.
Take
Now
out.
I'm ready to do U substitution. And another thing, guys, in this key step, pull out that -6. Yeah, so it's in the way. Pull out the -6. All right. So I have cos x. Okay, that's cos x. Have a look. This cos x cannot change. E to the power of. Remember, only U should appear. What can I write sin x as?
U.
U.
Very smart. Look at the board. Look at my arrow. U. And what can I write dx as?
1 over cos x times dx.
Is everybody okay so far?
Mhm.
Oh, what happens to the cos x's now?
They cancel.
They cancel. And you end up with only U's. Do you see? You have only U's.
Mm-hmm.
And my key step was this. If the x's do not cancel, you made a mistake. So everybody, before I move on to the next problem, everybody look at the board. When the problem began life, that cos x did not vanish, and that's okay. So I just copy that cos x. Have a look here. Have a look here. I'm just going to make substitutions for that step 1. Look at the board. Look at the board. Write this. I'm going to make substitutions only with step 1 and step 3. Is that clear? So that cos x was neither in step 1 or step 3 just yet. So I left the cos x alone. E sin x became EU, and dx became 1 over cos x dx, and the cos x cancel automatically. I don't have to do anything with that cos x. Is that clear? Okay, let's wrap up the problem. Now I'm actually wrapping it up. Okay, I'm going to switch to blue. Okay, -6. Ooh, what's the integral of EU?
EU.
EU. And who remembers what we just do in the last step? U is after all
Sin
sin x. I substitute back. Make a note to yourselves. In the very last step, substitute.
Rama, you made a mistake.
Where?
You said dx twice. If you look at inside the circle, then you brought it down again.
Oh, sorry. Thank you. That should be du, correct? That should be du.
Yeah, so in the function should be like 1 over cos x du. Yeah.
Thank you. That was a typo. Sorry. Thank you for that. And then plus C. Ta-da! And there's your final answer. In the last step, you'll substitute back. Remember, the question began life as x. I need to go back. Is that clear? Okay, this is the time anybody can unmute themselves, ask me questions. But this is the key step, guys. I'm highlighting the key step. When you make a substitution and simplify, the x's should just vanish. And only u should appear at the end of the substitution. Have a look. I just had e to the power of u du. All the x's just vanished. Okay, let's move on. Go to question number 9, please. Copy down 9. Okay, we're going to be slightly faster. Okay, u equals. Hint.
Tan
I have a
M.
sec squared m and I have sine of monkey. So what should I choose? U to be?
Tan
10m.
M? Is that clear? I'm choosing the complex guy. Wherever you have. See, sec squared m is there's no monkey there. But sine of tan m, I have a monkey tan m. Miss Flores, are you getting the hang of it? So that's why I'm choosing monkey. That's sine monkey. So that choose tan m. Therefore, du equals
Secant square m
secant squared m.
Tan.
dm.
Yeah.
Should I solve for dm?
Yes.
Yes.
Therefore, dm equals
1
1 over secant squared m times du.
by both sides with a reciprocal. Du. Is everybody okay there? Now, good habits. I'm putting bullet points to step 1 and step 3. Pull out the 2, good habits. Sec squared m stays the same and becomes sine of
U.
u, and dm becomes
1 over
1 over
1
secant
over
squared
sec
m
squared
times
du. Is everybody okay with that step? Ooh, what do you observe that happens to the sec squared m?
They
They
cancel.
cancel.
It cancel. It'll always happen. Ta-da! And you have only u's now.
Yes.
Yeah.
You have only u's. Okay, careful. Now we're doing integrals. What's the integral of sine u?
Negative
Negative cosine U.
sine.
Negative cos u. Is everybody okay there? Are we done with the problem? There's one final step.
Substitute.
Thank you. She got the hang of it. So is that negative 2 cos of, what is u after all?
Tan
Tan m plus c. Ta-da! Okay, everybody, look at your notes. Go to the big idea. Those of you who wrote the big idea. What does the big idea say?
Choose U so that
So
it's
that-
already present.
Okay,
Yeah.
Miss Ala sweetly says, choose u, so its derivative is already present. Everybody, put your pencils down and blowing your mind. What's the integral of tan m? Again, what's the
It's
integral of
squared.
tan m?
Wait, no.
Negative cosine.
No. What's the integral? Sorry. I'm an idiot. I'm so sorry. I was confusing you. What's the derivative of tan m?
Secant
secant
squared.
squared m.
Oh, it's already present. See, it's already present. See? That's what I meant by the derivative is already present. Let me do another one. Go to the previous problem. What's the derivative of sine x?
Cos x.
Ooh, cos x is already present. See? Do you see that? It will always work itself out. So choose u, so its derivative is already present with the dx. Okay? Okay, let's do more examples. Okay, copy down 12, please. Sorry, page 10. No, page 12, but question 10. Just copy down question 10. Okay, Mr. Manasra, what should I choose u to be?
Mm.
Mr. Manasra,
Cos 2x.
thank you. The monkey, choose the monkey to be u. Okay, do the next 2 steps yourselves. Careful, use chain rule. Do the next 2 steps yourselves. Those of you way ahead. Du equals,
Negative 2 sine 2m.
very good. Dx. For those of you who've forgotten, cos monkey is, excuse me, derivative is negative sine monkey times 2. Should we solve for dx?
Mm-hmm.
Just multiply the reciprocal. Don't think too hard. Go.
1 over negative 2 sine 2x times du.
Du. Is everybody okay there? Now we're ready to do the u substitution stage. So I'm putting bullet points. You know what to take care of.
5.
Okay. Love you. She says take out the 5. Okay. The sine to x stays the same. Is that clear?
Mm-hmm. Du.
Okay, go. E to the power of
U.
u becomes cos to x. Step 1. Have a look at the arrow. Cos to x just becomes u. And
Then
dx
dx.
just becomes
1 over negative 2 sine
one half sine to x. I just put the negative on top. It doesn't matter.
Du.
Du. Is everybody okay there? Oh! What happens to the sine to x's?
They cancel.
cancel.
Now, everybody, look at the board. Look at the board.
Wala ta-
Oh, okay, he got the hang of it. Bellarmino says we can pull out the everybody. Look at the board. Look at what I'm circling. I encourage you to circle.
5/2.
Can I take out the negative 1/2?
Yes.
So the upside number will really become
Negative 5/2.
Negative 5/2.
negative 5/2.
Mhm.
So I'm highlighting the leftover so you can see what's going on. Is the leftover only EUDU?
Yes.
see
Mhm.
Okay, let's wrap it up. EUDU, rewriting is your friend. So absolute final answer. We're ready to integrate now. And what's the integral of EU?
EU.
You.
What do we do? What do we remember to do in the very last step? Always.
Substitute
Substitute.
Thank you. Substitute for U. And what was U after all?
cos 2x.
Cos 2x. Oops. What? My screen froze. What just happened here? Okay. Cos 2x plus C. Are more and more students getting the hang of this? This is a small puzzle. Just treat it like a game. You just have to follow the rules of the game. Miss Chamberlain, unmute yourself. How are you doing? Are you confused? You're getting some of it? What's your status? Chamberlain. Miss Chamberlain? Mr. Manasra, how are you doing?
All right.
Mr. Al-Nabulsi?
Good.
Okay, guys, write down question 11. Okay, Mr. V, what should I choose you to be? Mr. V. Hint, you always choose the monkey to be you. Mr. V? I don't know if he's there. Ms. Valderrama, what should I choose you to be?
Radical K.
Love you. Radical K. Okay, go. Everybody look down. Look down. Therefore, du equals
1/2
1/2
radical K
radical
times DK.
K. I hope you're not getting confused with the variables. I hope you're okay. I can throw any letter. I can be an X. It need not be an X. It could be a K. Okay. And therefore, dk equals, guys, just multiply by the reciprocal. So what does it just become?
2 radical K
Two radical
times
K
Du.
times du is everybody okay there. I'm teaching you good habits.
Take
I
out the
put bullet points there. Okay, Ms. Chawla sweetly says, take out the 5. Okay. And remember, radical K is u. Wherever I see it, okay, so it becomes
Cosecant U.
cot cosecant
U.
u, cot
U.
u over radical K. That stays the same. And then dx is after all. Oh, sorry, guys, there's a typo there. There should be dk. Everybody, there's a typo there. That should say dk. Okay. And dk is after all
2
2
radical.
radical K
radical
times du.
K du. Is everybody okay there? Oh, what is that? What happens to the radical case now?
Cancel.
Cancel.
So,
And then 2
So it's 10. So pull it out.
thank you. These smart kids already say pull out the 2. So that'll become 10.
Yeah.
It becomes cosecant u, cot u, du. Do you see? Remember what I just said. In the key step, only u should exist. Do you see that? Only u's exist. Is everybody okay there? Only u's exist. And from second semester formula sheet, who remembers? Careful. See if you can recall your memory. Recall. What's the integral of cosecant cot?
Negative cosecant.
Negative cosecant u. Okay, because we integrate, I remove the integral symbol. So final step, it becomes negative 10 cosecant of, hint, what is u after all?
Radical K.
Radical K.
Plus c. Again, many kids forget to do the back substitution in the last step. At this stage, everybody, at this stage, I'm getting ready to integrate. Everybody look at the arrow. Once I read out everything in terms of u, I'm ready to integrate. Is that clear? In the last step, I just plug it back in. Ms. Madhya, how are you doing?
I'm doing okay.
Mr. No, how are you doing? Yes, Mr. Gurbani.
So what if instead of radical K on the bottom, you replace it with U?
Very smart. Everybody, I was hoping somebody would ask me that question. Mr. Gurbani says, everybody look at the board. He says, instead of the radical k on the bottom, I replace this with u. There's no problem there. So I would have a u there. And then remember, I would have 2 radical k on the right-hand side. Can I replace that k with 2u then?
You. And it would just
And
cancel.
will the u's cancel then?
Oh,
It would work itself out, Mr. Gurbani. If you're alive, keep it as long as you keep the rules of the game in mind. Remember, the rules of the game are when you do the u substitution, only u's should appear. There should be no k's. Did everybody understand Mr. Gurbani's question? He said, Rama, I see a radical k, and I know radical k is u. And I'm saying, fine, go for it. So radical k becomes a u, but then I have 2 radical k, and I should rewrite that as 2u then. And the u's will cancel. It'll work itself out. Because the goal, Mr. Gurbani, is when you're doing u substitution, there should be no original variable. The original variable should just collapse somehow. If it does not, you
You froze?
yeah.
Is he gone?
Back. No, he's back.
okay. What should I choose u to be?
ln x minus
X minus 1.
Very good. Ln x minus 1. Look down. Down. I'm going to walk you through it. Look down. Next step. Go.
du equals 1 over x times dx.
Very good. Therefore, dx equals
X times du.
x times du. Is everybody okay so far?
Yes.
Good. The more steps you do independently, the better off you'll be. Okay, I put bullet points here, bullet points here. I can pull out which constants can I pull out?
4 over 5.
4 over 5.
4 over 5, very smart. Integral. So it becomes sec square
U.
u, very good. Because I'm going right to left. Again, intelligence is observing patterns. Over x stays the same. And dx
Times
becomes,
du.
Do you?
and what do you observe happen?
X is cancel.
Cancel.
Cancel. What's your friend?
We writing.
So it becomes 4/5 sec square u du. Is everybody okay so far?
Mhm.
Okay, I want all of you to finish the problem. Take the integral, substitute, tell me the final answer. Look down, go. I hope you have memorized your formulas.
10.
10.
Okay, who remembers integral of sec squared u?
10.
10.
U.
ln x
What's the
minus
last step?
Substitute.
Substitute.
So it's tan
Tan.
of
ln
ln
x
x minus
minus
x
1.
minus 1, because that's what u is in the first bullet point. Plus c. Ta-da! It will always work itself out if you choose u correctly and you did not make algebra mistakes. Another thing, guys, everybody, here's a common mistakes weaker kids do. I'm writing in red. Look at the board, please. Do you observe the dx is in the numerator? The du is in the numerator. The weaker kids, I don't know how they do this. They write 1 over x and then dx here, and they get so confused. This is incorrect. The dx, du's, all of them are in the numerator. All right. Write down question number 13, please. Now, keep in mind the old rules. I'm emphasizing the old rules. Anything under the denominator is the monkey. Anything underneath the radical is the monkey. Okay, those are rules in the tips I gave you on that sheet of paper. I strongly encourage you to take a printout of that one page, just that one page. It's like page number 3 or something. Okay, for those of you who observe patterns, what should I choose you to be?
1 minus ln.
There are 2 rules I can use. The guy in the denominator, which is one, or sorry, the guy underneath the radical, I should choose to be u. Is that clear? Okay,
Yes.
therefore du equals
0 minus. Oh,
yeah, go. I'm just choosing not to write the 0.
minus
Negative 1 over p
Negative
times
1.
dp.
Mhm.
Is everybody okay there? Step 3. dp equals, okay, Ms. Andelko, what are you writing? dp equals,
dp equals negative p du.
love you. Everybody observe, she just took the reciprocal of this guy. The weaker kids say, I don't know what to do. No, you just keep taking the reciprocal of that guy. We're just multiplying by the reciprocal both sides. Okay,
Wrong, you made a mistake.
what did I
Yeah.
make?
like in the context of a problem, instead of dx, it should be dp.
Oh, yeah. Thank you. He says this should be dp. Everybody, that should be dp. Thank you. Everybody, make that change. That should be dp. Okay. Can I pull out the 3?
Yes.
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 That's 1. Guys, there's a 1 on top now.
Mhm.
That p here stays the same. It's okay. It just becomes radical of
U.
U.
u. And the dp is nothing but
Negative
Negative
p.
p du.
du. Is everybody okay there? Okay, write the next step yourselves. Finish the problem. Go on. Everybody finishes the problem. Look down. Advanced kids, what cancels?
The
P.
p.
Negative.
-3.
Negative 3. Rewriting is your friend. I'm just rewriting it.
Mhm.
You see, only use appear. Only use appear. Those of you finish. What is the integral of 1 over radical u?
2 radical.
2 radical u.
Absolute final answer?
Substitute.
-3 times 2.
Negative 6.
Absolute final answer?
-6. L and
Radical
Oh, 1 minus L.
plus c. Ta-da. Ms. Ramirez, how are you doing?
I'm doing good, thank you.
Okay. Guys, write down question number 14, please.
Rama.
Yes.
First of all, that's a mistake in the context of problem again. And the second thing is,
Okay, guys, this should be DL. Thank you. Yeah, go.
and the second one is, okay, when we get the interval at the last step, shouldn't we divide it by the slope? Always do.
But it's just radical u. It's radical x. What's the slope of x? Just 1?
No, but if like you have it like a numerator.
No. You're getting confused. Everybody, look at the board. Mr. Gurbani, what's the integral of 1 over radical u?
2 radical u.
2 radical u. So we already finished integrating, and the integral of u is just 1. So 6 over 1. So what are you talking about?
No.
In the last step, Mr. Gurbani, all I'm doing is substituting, man.
No, you didn't get my question. So instead of like 1 over radical u, is like 1 over radical 2u. Like it's like you have
Where is the 2?
like imagine you have it like in the context of problem, then we bring it down all the way.
No. I'm just asking you for a simple question. What's the integral of 1 over radical u? Where is this 2 coming from? The integral of 1 over radical u is 2 radical u. That's it. Hey, Gurbani, the u is like x. What's the integral of 1 over radical x? It's 2 radical x.
Okay.
That's it. And then u in the last step is 1 minus ln p. So I just plugged it in. That's it. There is no division of slope. It's if you divide by slope or something, it's like you're taking the integral again. No, but at this stage, Mr. Gurbani, I'm darkening the arrow. At that stage, I'm just plugging it in. I'm not integrating at this stage. I just substitute for u. So the only integration step, I'm drawing squiggles. The only integration step is here. That's the only integration step. Doesn't make sense because it had an integral symbol. At the last step, I'm just plugging it in. There's no integration going on. Okay. I understand your question though. On day 1, students have that question. But I'm saying, no. At that stage, we're just plugging in. We're not integrating. All right. Now, everybody put your pencils down. So this is one of those cases where our tips do not work. So I'll choose the big idea. So everybody, what does the big idea say? Feel free to flip back at your notes. What does the big idea say? Choose u so that
Its derivative is
derivative is already present. So I will choose, I'm giving you 2 options. Do not speak, do not write. I can choose u to be sine inverse L plus 3. Yes.
Mhm.
Or I can choose u to be 1 minus L square. Does everybody understand that?
Mhm.
Those are my 2 options. Those are my only 2 options for you. Okay, what's the integral? Sorry, what's the derivative of sine inverse L from first semester?
1 over
1 minus L square. Is that present?
Oh.
Yes.
Do you see that's present? 1 over, it's in the denominator. Do you see that? Okay, on the other hand, if you make a mistake and use this guy to be, what's the derivative of 1 minus L square?
0 minus 2L.
Do we have a 0 minus, do you have negative 2L somewhere here?
No.
That's not useful at all. Did you observe? Like the general concept is choose u, so its derivative is already present somewhere along the way. Okay, so write those two down and then cross this out. Because I'm teaching you how to choose u. You could say, hey, in the composite function, I could choose monkey cube or radical monkey, and I'm saying which guy will dominate. So, oops. So du equals 1 over radical 1 minus L square dl. Everybody okay there?
Yes.
Mhm.
Therefore, dl equals
Radical.
1 minus L squared times du.
du.
everybody okay there? So I put bullet points here. So it becomes integral. What does the numerator just become?
U cubed.
Thank you. U cubed. The denominator stays radical 1 minus L square.
Mhm.
And what is dl after all?
Radical 1 minus L squared du.
Ta-da! And what happens to the radical 1 minus L squares?
Cancel.
They cancel.
Cancel. Is that clear? And then simple power rule, guys. What's the integral of u cubed?
U to the 4th over 4.
To the fourth.
Everybody okay there? And absolute last step. What was u after all?
Sine inverse of L plus 3.
To the power of
4.
plus c. Okay, before I move on day one, everybody, this is a day one problem. Repeat, this is a day one problem. If you do not attend office hours, you're likely to be confused on your homework. Look at the board of this confusion. Put your pencils down. When you do u substitution, everybody, I'm writing in blue. Is it tempting to kind of solve for radical 1 minus L square and plug that in somewhere? Is that tempting to do? Because remember, I say u substitution and kids say, okay, what is radical 1 minus L square? No. You just do step one. Once again, there's a reason I put bullet points here and bullet points here. Replace the original one. Okay, that's that guy. Is u. Leave the radical 1 minus L square in the denominator alone. Because in the next step, when you replace dl equals, this is the bullet point. Sorry. dl equals radical 1 minus L square, they will just cancel. Is that clear? Many students say, okay, so but what's radical 1 minus L square? I don't care. I'm just going to write that and then plug in for dl, and the radical 1 minus L square will just cancel. Okay, don't overthink the problem. It'll just work itself out. Okay, right on 15. If the previous problem made sense, you should be able to do this entire problem yourselves. Okay, see if you can do the entire problem yourselves. Go. Okay, look down. Smart kids, should I choose u to be tan inverse n or 1 plus n square?
Tan inverse.
Tan inverse n.
Because if you know your formulas, what's the derivative of tan inverse n?
1.
1 over
1
1
over
One
plus
plus n square. Is that already present? Is that already present? Do you see the logic?
Mhm.
Okay, look down, look down. So do you see the big idea, the power of that big idea? Okay, Miss Flores, what's dn? Miss Flores, unmute yourself. What's dn? I'm just taking algebra skills. Miss Juarez or Miss Flores, what's dn? Again, Miss Chamberlain, Miss Flores, or Miss Juarez.
1 plus n squared dn.
You mean du?
Yeah.
Love you. Okay. Guys, good habits. What can I pull out?
Take out the
The
3.
3.
Out the 3. So that's a 1 left over. Don't freak out.
Mhm.
Okay. What is the u substitution I'm making?
U squared.
U
U
squared.
square. 1 plus n squared
plus
stays the
n
same.
squared.
And what is d? Oh, there's another typo. That should be dn, correct?
Yes.
Yeah.
And guys, what's dn after all?
1 plus n
1
squared
plus n
du.
squared. Du.
And what do you observe happen?
The 1
1
and squared cancel.
Let's wrap it up. Ooh, for those of you who remember your formulas, what's the integral of 1 over u square?
Negative 1
negative
over u.
1 over u.
So absolute final answer, negative 3 over
10
And
inverse
inverse
of that.
10.
plus c.
Plus-
Ta-da! Are you getting more and more comfortable?
Yes.
Yes.
Again, the key step is after you finish doing u substitutions, eventually, about 20 seconds down, all the other variables should just cancel and the u should be left over. Okay. Copy down question number 16, please. Okay, Mr. Manasra or Mr. Al-Nabulsi, what should I choose you to be? Again, Mr. Manasra or Mr. Al-
2x.
Sorry?
2x.
Do you really intend to say 2x? Did you intend to say 2x or did you intend
2 over x.
to
Oh,
over?
yeah. My bad. My bad. I'm
Okay,
freaking tired.
It's fine. Both of you, tell me the next step. Both of you. Either of you can keep calling out next. Go.
I'll get the derivative.
U equals. Go.
Oh, negative 2x squared.
You mean negative 2 over x squared.
Yeah, over x squared.
Dx. Go.
Reciprocal, which is negative x squared over 2.
Love you. Du. Okay, guys, we're ready to do u sub. So can we pull out that 3 on the top?
Yeah.
Yeah.
Okay, don't freak out. Guys, the variables should stay in the inside. So that's 1 over x squared.
Mhm.
Okay, sec
Secant
U.
u,
U.
tan
U
10 u.
u. And what is dx after all?
Negative x.
negative x squared over 2 times
Over
u.
2 du.
U.
Okay,
That's
finish the problem. Cancel, adjust the numbers, finish the problem. Go. Cancel terms. I'm guiding you. Okay, Mr. Manasra or Mr. Al-Nabulsi. Go. Next step.
Cancel the x squared.
Love you. And then what happens to the outside numbers?
You take out the negative and the negative 1/2.
So it'll become negative 3 over 2.
Yeah.
Rewriting is your friend, guys. Let's wrap it up. Look down, du. Do not forget the du operator. Those of you wrapping it up. What's the integral of sectan?
Secant
Secant.
U. So
Absolute last step. What is u after all?
2 over x
Ta-da!
plus c.
Check if you got this all by yourselves, pretty much, for the most part. Okay, any questions? Ask me now. Ms. Ramirez, how are you doing?
I'm doing okay.
Okay, please follow the same process over and over again. I hope to see you during office hours, silly girl.
Yes, you.
Guys, write on 17, please. Okay, Mr. V or Ms. Madiedo, you can answer the next question. You guys are guiding me for the rest of the problem. Again, Ms. Madiedo or Mr. V, what should I choose you to be?
3t squared plus 4t minus 1.
Go. Next step. All of you, you're doing it yourselves. These guys are just helping us. Go.
Equals 6t plus 4.
dt. Don't forget the dt.
And then
Therefore, d equals
1 over 6t plus 4 du.
everybody stop. You're learning something new. Can I factor something?
2.
2. Very smart. Everybody observe this. If you can factor, you should factor. Repeat. Sorry, I meant a 2. If you can factor something, you must factor. Is that now 3t plus 2?
Mm.
Mhm.
Is everybody okay there? And you'll
Yes.
see magic happen. you'll see magic happen. So equals integral 3t plus 2 e to the power of
U.
u. And what's, oh, there's a typo there. That's supposed to be a dt, right?
Yes.
And what's dt after all?
1
1
over
over
2
2 times
3
3t
plus
plus 2
du.
times d.
du. What cancels? Look down, look down.
3t plus 2.
3t plus 2.
You could take off the 2 at the
What gets pulled out?
1/2.
1/2. Love you.
Mhm.
What's the leftover?
EU.
EU over 2? Oh, wait, no. Just kidding.
No. We pulled out the 1/2.
Just kidding, just kidding.
So EU, du. Don't forget the du. Okay, let's wrap it up. What's the integral of EU?
EU.
u.
EU?
Are we done with the problem?
No.
So-
substitute.
So what's the final answer?
1
1
half.
over 2 e
Power
to
of
the power of 3t
14 minus
plus
1.
4 t minus 1.
Mr. Smith, are you working? I see you typing. What's the typing about?
We'll see.
Are you doing something else?
checking something.
Sorry?
I was just quickly checking something on the computer. I'm doing the work.
Okay, if you attend office hours, I'll do this problem, but otherwise we're moving on. Copy down number 19, please. Okay, Mr. Patel or Mr. Saldana, unmute yourselves. Repeat, Patel and Saldana. You guys are helping me with this problem. Go.
U equals 3a squared minus 11a plus 5.
Very good. Go. Saldana, participate. Du equals?
Du equals 6a minus 11.
What is he forgetting to write?
dA.
dA. Okay. And then last step. dA equals?
1 over 6a minus 11 times du.
Very good. Okay. Equals 6a minus 11 stays 6a minus 11. There's no substitution there. And the denominator just becomes?
Cubed u.
Cube root of u. dA just becomes?
1 over 6a minus 11 du.
Ooh. What do you observe happen?
That's
Okay, guys, first semester. Who remembers how we integrate 1 over cube root of u? We should rewrite this as u to the power of?
1/3.
1/3? Negative 1/3.
Negative 1/3. Thank you. In the denominator, right?
Yes.
Okay, look down, look down. Let's use the power rule. Look down. So, hint, add a 1. So it becomes u to the power of?
2 over 3
Times?
3 over 2
over 2?
Absolute last step. At this stage, guys, we're just plugging in.
Substitute.
So u is after all?
dA squared minus 11a plus 5 over 2 up to the power of 2 over 3.
Plus c. Ta-da! Wasn't bad at all, right?
Yes.
Okay, 20. Which insanely smart fellow will tell me how to do the problem?
Long division?
I love you, Bellarmino. He says long division. Can you see? I was deliberately confusing you. You'll be tempted to do u substitution. Everybody, look at me. Just because we do 100 problems u sub doesn't mean every problem is u sub. Is that clear? Every problem is not u sub. No, we're not going to do long division, but I'm just showing you. I just threw in a long division problem to deliberately break the routine and saying, hey, are you being aware? Just make a note to yourselves. We'll do this in office hours. Just make a note to yourself, long division. There's no u sub there. Okay, guys, all of these examples, if you're responsible, I will do during office hours. But right now, I need to move on. We need to finish the lesson. Oh my God, I need to do one of these. Oh my God, I'm way behind. Copy this example down, please. Right on page 30. Oh my God, I'm way behind. Okay, u equals?
X plus 3.
Plus 3.
Therefore, du equals?
1.
dx?
Yes.
Therefore, dx equals?
What?
du? Yeah, it's okay. It's just du. It's okay. Okay, so integral x plus 1 over radical
u.
u. And dx is nothing but?
du.
du. Stop. Mr. Smith, pay attention to this problem. Stop. We have a problem now. Do you see all the x's do not collapse? Do you see that? The x's do not collapse. Which insanely smart fellow will say, Rama, x is actually this. You can plug in for you. What is x after all? Be alive. What is x after all? Hint. Look at step 1.
U.
U.
No. What is x? Look at what I'm look at my bullet point.
U
What
minus
x?
3.
U minus 3.
Oh, I love you. He says x is u minus 3. Do you see that? So I'm making a substitution. Draw a skull. So this is a problem where the x's do not collapse. So we just say x is nothing but u minus 3. Can I now plug it in?
Yes.
So x is u minus 3 plus 1 all over radical u. Is everybody okay there?
Yes.
Can you see only u's appeared? Only u's appeared. Okay, let's simplify this. Is that u minus 2 over radical u? Who remembers from the first semester how we did that problem? Does anybody remember?
Separate.
Yeah, split it up, separate them. Is that u over radical u?
Yes.
Is that u to the power 1/2 minus 2 over radical u, correct?
Yes.
And isn't this guy nothing but just u to the power 1/2 because we subtract? And then minus 2 over radical u. I'm not doing anything there because don't we have a formula for that? I'm leaving it alone. And then last step, I'm ready to integrate. What's the integral of u 1/2?
U to the power
3
3
over
over
2.
2. X 2 over 3.
2 over 3.
Also over 3. Yes.
Minus 2. And what's the integral of 1 over radical u?
2 radical U.
Radical U.
Now, can we plug in what was u after all?
X plus 3.
X plus 3 to the power of 3/2 minus 4 radical x plus
X plus 3 plus C.
Did everybody observe how that problem worked out? So the key step, you will split it up. Okay, I have to do one more problem like this. Write down 31.
Rama, I think you made a mistake.
No, I did not.
And the powers, like 3 over 2, then it's like 2 over 3?
Yeah. Multiply by the reciprocal.
Okay. Oh, never mind. Okay.
Okay, everybody, write down 31. Okay, I want to see if learning happened in the previous problem. U equals, therefore du equals
1.
Just 1.
DK.
dk. Therefore dk equals
U.
U.
So the integral becomes, okay, for the kids who now advanced skills, we can write k as
U plus 1.
u plus 1. Very smart. Everybody look at my arrow. So k is nothing but u plus 1 because that k is not going to cancel. That k is not going to vanish. So k is nothing but u plus 1
Plus 2.
plus 2. Put a parenthesis so you don't get confused. And will that just become radical of u? And dk is nothing but du. Did everybody observe? Only k's appear. And that just becomes u plus 3. Can we write that as u 1/2? Okay, who remembers in the first semester how we did this problem? What do we do next time?
Distribute.
I love you. Okay, distribute. Does that become u to the power of 3/2
Yes.
plus 3u to the power of 1/2?
Yes.
And can we totally integrate that?
Yeah.
Okay, stop. I'm just going to say finish. And then plug in, correct? Because the last concept of the day, my God, I should have done this problem. Is this. Okay, I'm going to scroll down. Now, all of these are for office hours. Okay, write this down. U substitution with definite integral. This is the key thing. Last idea of the day. Write down the topic. U substitution with definite intervals. Pay very, very close attention for the next 10 minutes. Because I'm teaching you a shortcut. Is that clear? I'm teaching you a shortcut. Okay, go. What is U?
X squared plus 1.
Everybody okay there? Just choose the base of the higher power. Therefore, du equals
2x.
Times ds.
Therefore, dx equals
2x.
1 over 2x times
1 over
du.
2x du.
Is everybody okay so far?
Yeah.
Okay, now you're learning a shortcut. Everybody, you're learning a shortcut. write down this. This is x equals, and this is x equals. The lower limit and upper limit are in terms of x's, correct? I'm going to do u substitution. Mr. Smith, pay close attention. I'm going to do u substitution. Therefore, the x limits will turn to the u limits. So here's how I find the u limits. Put a box here. I'm going to plug in the upper limit and lower limit for that box. Okay, play along. Guys, I have a typo. Make the upper guy, make the upper guy say 2. Make the upper guy 2. Just play along. Make the upper guy 2. Okay, when x is 2, I'm plugging this in here. In case you're saying, what are you doing? What is 2 square?
4.
Plus 1?
5.
Those are your new u limits. Is that clear? When x is -1, what's -1 square?
1.
1.
Plus 1?
2.
Did everybody observe the new u limits? Okay, now I'm ready to do u sub. Can I pull out the 3?
Yes.
Okay, leave the x alone. What can I add x squared plus 1 cube as?
U.
Cube, don't forget. And what can I write dx as?
1
over 2x times u.
X cancels.
Everybody okay there? What do you observe happen?
The x cancels and then the upper becomes 3 over 2.
Very smart. She gives me 2 steps. She says x's cancel and becomes 3 over 2. And now I'm going to stop writing the u. So is that just 2 to 5? U cube du. Is everybody okay there?
Yes.
Now everybody, look at the board. The new variable is u equals. In other words, I do not need to do a backward substitution. Just play along. What's the integral of u cube?
U to the 4th over 4.
U to the power of 4 over 4. Now here's the key step. I do not do a backward substitution. Do not substitute for u for a definite integral. Do not substitute for u. Why? Because I already changed the limits. I have a 2 and a 5. They're in terms of u already. Do you see that? They're already in terms of u. So I can just plug that in. So 3 over 8. What's your upper limit?
5.
To the power of 4 minus 3 over 8.
2 to the power of 4.
2 to the power of 4. And that's your final answer.
Over 4.
That is your final answer. The key step is this. For a definite integral, you're not plugging back in because we changed the limit in the very first step. You get it? Relax, we'll do a couple of more problems. You get a feel for this. Again, you need to understand that for a definite interval. We're going to change the limit of the variable. So we're just plugging in the new limits. We're not doing a back substitution. Just play along. Okay, copy it on number 2, please. Again, this is u sub with definite intervals. Okay, go. U equals
1 plus 2x squared.
plus 2x squared. Du equals
4x times dx.
dx. Do not forget the weaker kids just say 4x. Therefore, dx equals
1 over 4.
1 over 4x times du.
Again, the weaker kids just say 1 over 4x. This is a du. Okay, smart kids who've got the hang of this. What is your new upper limit? Look at my arrow. What is your new upper limit going to be? Actually, better. What's your
9?
Okay. Yeah. 2 square
4.
4.
times 2
8.
8
plus
9.
1
9.
9. What's your new lower limit?
1.
1.
1. Did you get the hang of this?
Mm-hmm.
Okay. So can I pull out that 6?
Yeah.
X over radical
U.
What's dx after
1 over 4.
1 over 4x times du.
du?
X cancels out.
X cancels out.
6 over 4. So
3 over 2.
3 over 2.
Or 3 over 2. Go. Is that just 1 over radical u du?
Yes.
And wrap it up. Look down. What's the integral of 1 over radical u?
2 radical u.
2 radical u with lower limit being
9. No,
1.
1. Upper limit being
9.
Can you see you're not back substituting in a definite integral? It's very easy because we changed the limits. Already. Okay, let's wrap it up. Remember, you guys said 3 over 2 correctly?
Mhm.
Will the 2's cancel?
Yes. 3.
Yeah.
3. Okay, the 2's cancel. And radical of 9 is
Three.
3
So
minus
3.
3. Square root of 1 is
1.
1.
so 3.
final answer.
6.
Ta-da! Is this kind of fun? Again,
Yes.
for a definite interval, please understand this really, really well. Valderrama, sweet girl, are you with us?
Yeah.
Okay, guys, the key step. Mr. Manasra, I hope you'll, Mr. Al-Nabulsi, because Manasra does. Al-Nabulsi, please attend office hours today. Okay, write on number 3, please. We have just 2 more problems to do, then we're done for the day. Write on number 3. It says average. So how do we always do average problems?
AV equals
1 over 4. Integral from
0 to 4.
or f of x dx.
I'm directly plugging it in, yeah? Whoa! Is that now a U sub problem? Do you see that? Okay, go. U equals
Radical x minus 1.
radical x minus 1. Therefore, du equals
1 over 2 radical x times dx.
okay, dx in the numerator. Therefore, dx equals
2 radical.
X du.
very good. Equals 1/4. Smart kids. What does the upper limit become? Hint. Look here. Look at my circle. What does the upper limit become?
1.
1. Square root of 4. 2 minus 1 is 1. What does your lower limit become?
Negative 1.
Negative 1.
Negative 1. Everybody okay there? Okay, 3
E to the
e to
power
the power of
U.
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 The radical x stays, and dx is nothing but
2 radical
2 radical.
2 radical x.
u and the
U.
radical cancel. So we
The
have the
radical x cancels. And what number? Look at what I'm circling. What number can go outside?
6 over
6.
Can we write 6
over
over
2.
3 over 2.
Yes. You guys are way ahead. Integral -1 to 1. Is that just EU?
Yes.
Yes.
Let's wrap it up. What's the integral of EU?
EU.
U.
EU. Do we have to back substitute or are we good to go?
No. No. we
No.
just go.
He says, no, we're good. Lower limit -1, upper limit 1. So
Yes, yes.
absolute final answer, E
Minus
minus
1 over E. Over
1 over E. Everybody okay there?
Yes.
So, guys, so a definite integral is not bad at all, right?
No.
No, you just do a substitution the very first step. Is that clear? Okay, somebody said Rama. Some girl said Rama. Go.
Yeah.
Who said Rama? Okay, last problem of the day. Everybody, last problem of the day. I'm blowing your minds. Write that problem down. We may not have time to do the entire problem. We'll just set it up though.
Holy.
I'm drawing connections.
Oh.
Which concept?
Net change corollary.
Chawla smartly says net change corollary. Can you see? So I need, oops. Okay. So f of pi over 2 equals
F of 0.
f of 0 plus
integral 0 to pi over 2
f dash of x.
x dx.
Everybody okay there? Ooh, and if that is f dash given to us.
Yes, -2. I mean,
Okay, f of 0 is -2 plus integral 0 to pi over 2 f dash is 6 sine, relax.
This is gonna be interesting.
No, relax. It works out very fast. Trust me. Okay, what should I choose you to be? Okay, what should I choose you to be? Bellarmino, shut up.
cos 3x.
3x.
You're disturbing the class. Cos 3x. Look down. Therefore, D. Bellarmino.
That was not me. That was not me.
Okay, guys, what's the slope of cos monkey?
Negative sine
Negative sine
x times
monkey
2.
times 3
So -9
times dx.
Therefore, dx equals is everybody okay so far?
Yes.
Okay, try to do it yourself. Okay, equals -2 plus smart kids. Should I change the limits?
Yes.
Okay, so is that sidebar? Is that actually cos 3 pi over 2? correct? I'm plugging, draw an arrow. I'm plugging p pi over 2. This is this guy here. What's the cos formula?
X over R,
X over
X value.
0.
0. Okay, that's easy. Upper limit is 0. Okay, let's plug in the lower limit. Okay. What's cos of 0?
1.
1.
Everybody okay there?
Mhm.
Okay. 6. Sine 3x stays sine 3x. And just becomes e,
To the power of
Are
u.
you
and dx just becomes
1 over
Over negative
sine 3x du, and collapses and just becomes, oops,
negative 2.
Negative.
Negative 2 in the outside.
okay, will that collapse with that? And that will just become negative 2. Everybody okay there?
Yeah.
So it's negative 2 plus integral 1 to 0. Is that just 2 e u du?
Yes.
What are the negative 2?
Negative 2.
Can we wrap it up? Look down, look down.
Mhm.
And what's the integral of eu?
EU,
U.
With lower limit,
1.
upper limit.
0.
0.
Okay, stop. Did you observe how crazy the problem began and Bellarmine was freaking out? I'm saying, no. When you do the U stuff, it'll just work itself out very fast. As long as you don't make mistakes. As long as you don't make mistakes. Okay, put your pencils down, please. Put your pencils down. Now, I will tell you, this was a fairly challenging lesson. I will tell you. So for your own sakes, for those of you who say, I'm still a little wobbly, for your own sakes, please be ultra responsible and attend office hours. Is that clear? All right. We will meet at 1. You guys are good to go. Okay. Thank you, guys. Love you.
Bye.
I think you want to say.
Now, the new kid, I want you to stay back. Let's see. Mr. Tobias, stay back, please.
Yep, I'm still here.
Okay. Did you do derivatives, integrals? What's your status? How lost are you?
I mean, I was in a phase where at first I was confused and then I got it. And then you went to something different and I was confused again. And it's just, over and over.
Okay,
But
I understand.
more or less.
Okay, I understand. The other thing is, I want you to read the email I sent you very carefully that tells you the expectations of the class. All right. So, oh, by the way, are you transferring from another school, or are you just coming from virtual to
I'm coming from another school in Nevada.
in Nevada? Okay.
They do math very differently. So
Okay.
that's why
Right.
it's so.
Yeah, I understand that. Okay. To what extent have you memorized your derivative formulas?
Formulas, not that much actually. So I
Okay.
actually have a tab pulled open on the derivatives of trigonometric functions.
Okay, no, but I yesterday on Google Classroom, I don't know if you observed it, I actually shared a formula sheet. So I'm sharing my screen so you can see. Okay, 1 second. I don't know if you know how to navigate Google Classroom.
This thing.
So yesterday evening, I've posted here. It says derivative and integrals
Yeah,
formula.
I just found that. Yeah.
Yeah. So you need to download that. Take a printout. Okay, take a printout. So this page 1. Can you see the same problems involve derivatives and something called anti-derivatives or integrals? Did you have a chance? I don't know what your progress in the old school was. Do you remember seeing the symbol? Do you remember doing integrals at all?
Integrals, I think we had just gotten into that, but you see with us, I've actually already done a full year of AP calculus. They pushed a full year into 1 semester. So it went very, very fast and it was very hard to keep up, to memorize.
Okay. Are you a junior or senior?
I'm a senior.
Okay. So here's your challenge. Actually, I can stop recording this. Here's your challenge. You kind of have